Hey, I'm Brandon Graysley. I'm a high school math teacher. We're going to solve some equations that just involve addition and subtraction. So we'll start off with something like this. X minus 7 is equal to 25. So we're trying to find the value of x. We want to solve this to find the value of x that makes this equation true, and there will only be one in this case. To do that, we have this number. When we subtract 7 from it, we get 25. We're going to do the inverse operation to both sides of the equation in order to find out what that value of x must be. So here's what happens. The inverse operation, the opposite of subtraction, is addition. So we will add 7, and we have to do that to both sides of the equation in order for the equality to be true. So we've carefully chosen this inverse operation, though, so that when we subtract 7 and then add 7, when we collect those terms right here, they cancel each other out, or they add up to 0, and we have just x on the left-hand side. And on the right-hand side, we collect these two like terms, and we get 32. So we've now solved this for x. We've found the single value of x that fits in this equation that will make it true. And we can check that. The way we check is with a left side, right side check. The left side of the original equation is x minus 7. The right side of the original equation is 25. And we will substitute in the value for x that we found to see if it makes the equation, or if it matches the right-hand side after we simplify. So I've substituted in 32. 32 minus 7 is equal to 25, and yes, that's the right side. So since the left side is equal to the right side, we know that x must indeed be 32. All right, let's do a few more. 14 plus x equals negative 10. This one you can see is in a slightly different order, but we have the same thing. It's 14 plus this unknown number gives us a value. We can undo the 14 by, again, subtracting it. Let me write it like this. We have 14 plus x, and then from this side of the equation, we will subtract 14. That will clear out that 14 for us. And we will do the same thing on the other side of the equation so that everything stays balanced. So we performed this operation on each side of the equation to modify each expression. On the left-hand side, we have x. On the right-hand side, negative 24. So again, we have just x here because we have a 14 plus x and then minus 14. And these two things balance each other off, and we end up with just x when we collect those two terms. We can perform that same left side, right side check again if we want to, but I'm just going to move on. Let's try this one. 3x minus 1, oh, sorry, I didn't write that very nicely, is 2x plus 8. This one's a little harder to see just by inspecting. Some of the earlier ones, it's easier to just, you can kind of use your brain a little bit and say, oh, the value that must fit here is this. As they get more complicated, though, we really need this strategy of adding inverse values. Now we have variables on both sides of the equation. We have constants on both sides of the equation. We're going to want to have all the variables on one side and all the constants on the other. And we typically like to have the variables on the left. It doesn't actually matter. In this case, I'm going to do that because it will work out a little nicer for me. First, though, I'm going to deal with this constant. I don't want this negative 1 over here. I would prefer if all the constants were on that side. So to get rid of that, I will add 1 to both sides. 2x plus 8, and then I will add 1 to this side. There we go. So these two lines are exactly the same, except I've added 1 to both sides now. So the equality is still going to be true for the same values of x. Over here, collecting my like terms, I end up with just 3x, because minus 1 plus 1 is 0, and so it doesn't affect this side. Over here, I still have an x here, 2x, and my constants added together will give me 9. Okay, well, I have this variable term over here. I would prefer if all of my variables were on this side now. So I will do the same kind of thing. I'm going to subtract 2x from both sides of the equation. I've chosen to subtract 2x because over here I know that these two terms are going to balance each other out, and I'll be left with just 9 over here. So on this side, let me collect my like terms. 3x minus 2x is x. And over here, my 2x minus 2x, so plus 2x minus 2x, that goes away, that's 0, and I'm left with just 9. And I'm at the end now, x equals 9. And again, that left side, right side check. You would start with this left side, substitute in the value 9 for x, and evaluate it, and do the same thing on the right-hand side. Substitute 9 for x and evaluate it, and make sure you get the same number for both of them. Okay, let's do one more. 5 times 3x minus 7 is equal to 2 times 7x plus 4. And I hope you can see now, this is the kind of place where it would be pretty hard to just try a number. Even if you knew it was going to be a whole number or an integer, trying out some random things in here might be kind of slow. So let's deal with this using our technique. Well, first of all, you'll notice that it doesn't quite look like this one here because we have all these brackets everywhere. These are two nice little polynomials. These ones are a little grosser. So we will use some strategies that we already have. We know about the distributive property. I can simplify or expand this by multiplying 5 by each term inside the brackets. 5 times 3x is 15x. 5 times negative 7 is negative 35. I've now simplified the left-hand side of the equation so that it looks a little more like what we have up here. I'll do the same on this side. Distributive property, 2 times 7x plus 2 times 4. That'll be 14x plus 8. Once again, let's deal with the constants first. I would like my variables over here, so I will get rid of this negative 35. I do that by performing the inverse operation. The inverse will be adding. I'll add 35, and I have to do that to both sides in order for the equation to stay true. So there we are. This side, these guys are going to balance each other off, and I'll be left with just 15x over here. On this side, I have 14x plus, looks like 43. That's 8 plus 35 together, give me this 43. I'm a little closer now. I still have this variable term on this side. I would prefer if it was over here. So let's subtract 14x from each side so that this one will go away. Minus 14x. These two balance each other off. That's how I've crafted this adjustment to my equation, so that on this side I'm left with just 43, and over here, 15 minus 14 is just 1x, and we don't write the understood 1, and x is 43. Now for all of these examples, we always ended up with just x equals a number, and that doesn't usually happen. These ones are kind of carefully made so that that does happen. But in practice, what will typically happen, or often happen, is there'll be a coefficient on the x term, and we're going to do that next time.